Let's talk about why Python is such a popular choice when it comes to working with data. So Python is like a very popular choice, not just for data analysis. You can do a lot and lots of things with data. And first of it's the number one language for data science, AI, and business analytics globally. And over 70% of professionals in the field of data use Python, and that's a use percentage. So what makes Python so powerful and why is it so popular? Because it's very user friendly, it has simple syntax, and it is also very easy to learn, even if we are just starting out. Plus, it's open source. So by open source, I mean it's freely available in the internet. You can download, install on computer, and start working. And it has rich ecosystem of libraries and packages. I will talk about what libraries and packages are later in the workshop session. Like pandas for data analysis and matplotlib for data visualizations. What can we do with Python for data? So a lot. We can start with very simple data cleaning and pre-processing and getting our raw data ready for analytics. And we can also throw on those numbers into like beautiful charts using data visualization and exploratory data analysis, which helps you understand patterns and relationships in your data. Honestly, and if you want to go further, Python opens the door to machine learning, AI, and even automation. The possibilities go way beyond what we will cover in the workshop, but for this workshop, we will just focus on basic data analysis, the essential things just to get started. And here are just some example screenshots of what you can produce using Python. Heat maps, bar charts, summary tables, and these visuals actually really help you spot patterns in your data, like comparing categories, summarizing data, and more examples can be found using our previous datathon posters over our data space. And don't worry if you don't know what that all means. Later in the one hands-on session, we will create similar tables and charts together, so you can see how simple it is. So what we are getting into today, we will start by very simple loading and exploring data, inspecting what columns are in our data, and loading and validation with running a quick check on data, missing values and duplicates. And then we will move into data manipulation, things like selecting columns, filtering with some conditions, sorting and creating new columns in the data frame. And we will do EDA, explorative data analysis, looking at summary statistics, comparing different categories and identifying trends, and making some insights. And we will wrap up with visualizations. We will make some simple plots to show distributions, relationships, and group comparisons. So this is important for the workshop, development environments. So installing everything individually like Python and like packages can feel very overwhelming, especially if you are new and it's just starting out. And that's where development environments come. So they make life easier by giving everything ready. Like all the Python and all the libraries are already installed and it's on the internet. It's on some cloud platform. So you can access just through your browser and just logging into your Google account and you can start coding with Python. And Anaconda is a similar development environment tool. It's a free but locally installed Python distribution for coding. Let's say you have some sensitive data you are working on and you don't want to upload it into internet or cloud platforms like Google Colab. So you install Anaconda and you start working on that data. And use Google Colab. It's highly recommended using Google Colab if you are working on some open access data, like some free accessible data and not the sensitive data. And like for Datathon, if you're working on any project, you are working on some open data set, and you can use Google Colab to do data analysis. So again, we can help you provide the installation guide for like Anaconda. Again, you can come to our data space and uh, and we will help you. So for this workshop, we are using Google Colab. Again, it's a free browser and you just sign in with your Google account and there is no installation needed. And everything is ready to go, like popular Python libraries are already set up and it's also easy to share your work together. And it provides easy collaboration. And it also has like a AI assistant built in these days. So uh, so you can so AI will give you code recommendations as you are coding, and you can also troubleshoot your problems as you work. And it even gives you like a free access to GPUs and TPUs, like extra power for big tasks. Now we can officially get started with the hands-on session. First of all, we need to go to Google Colab. And I'm already signing. Make sure you sign in using the. So we can create a new notebook, go to file and new notebook drive. And you can see like this is an AI assistant and this is your coding steps. And you can name it something like work Python. So IPYNP is like a tag for, so every notebook has like .IPYNP. And let's say like you finish coding and you want to locate, you want to see your code again and you want to locate where this file in your drive, you can go to files and locate it back. It's here. I have other project folder. If you have just started working with, you will only see one. The next thing is accessing the data set. I hope everyone has the data set that we will be working on. I hope everyone has the data set and renamed it. Workshop 2. Now we need to bring the data set into the Google Colab. So you download it into your local like computer. Now we need to bring it here. So you go to this folder icon and upload this data set. Now we have brought it to this Google Colab. We will start coding. And the very first thing you will notice is we have this cell. You can add more like cells and you can designate each of your tasks in like one cell. And every time you work with data, you always start with importing some library. And you say import pandas. And pandas is a library. And you can import pandas as some other name, like a shortcut name. And people usually analysts use like PD as shortcut for pandas, and they import every time pandas as PD. And there will be more libraries we will be using like matplotlib and for data visualization, but for now, just pandas is enough. And we can create another cell. And now we brought it to Google Colab, but we need to bring our data set to the coding notebook, right? So what we can use the method from pandas library, pd.read csv inside the quotation mark, the name of the data set. workshop 2 dots, yes. And you store it in some variable, like people usually prefer DF because DF stands for data frame. And now, okay, let's run this cell. This is a run button, and you can see like a green check mark. This means it successfully ran without any error. Again, let's run this cell. Yeah, we were able to read the data set successfully. And this is how you validate. Let's say if you were like trying to import some other data set, it will give you an error. Like there is no any workshops 2.csv because we have only workshop 2.csv. So this is how you import and validate the data sets. Now, like in Python, in my first workshop, I talked about variables. So in Python, you have variables like containers. They can store single values or list of values. Now, you can also store like entire data set into a variable. And df. Df just stands for data. You can name it anything you want. But this is a popular choice. And let's say we want to, before doing any data analysis, we want to explore and inspect our data set, right? And there are some methods that you can use to just view your data, like df.head. If you run it, the df.head gives you the first 5 entries of this data set, right? And you can manually enter like 10, and it gives you the first 10. And you can see that it has age, gender, religion, marital status, like insurance plan, annual premium, and income in millions, these columns. So we can say like this data set is somewhat related to health insurance, annual premium, something. And we could do like many things like analysis on these data sets. Like we could compare annual premium amount based on the gender or based on the smoking status, right? And based on where they are from, based on their medical history, and so on. But before we do any analysis, I can see some NaN values here. Like there is also an NaN value. So this data set is not completely clean. It has some null values, some values that is not present in here. So before we do any data analysis, we have to make sure like our data set is completely clean, that there are no any like duplicate values. And I'm going to show you how you can check for null values all at once, and like just using a single line of command, you can like look for all null values, you can remove all null values, you can remove all duplicate values and get the data frame rate. I'm gonna add a new cell. And just like a head method, there is a tail method, like df.tail, that will give you the last 5 entries. And you can also df.save. df.save gives you the number of rows and columns this data set has. So this has like a 10,000 entries and 12 different columns. These are the columns. And so every time I'm using this df, and df is a data frame which you use pandas to store it in it. And then we are using dot methods, like methods to explore our data. Similarly, you can, so in notebooks, it only run the, if you don't use a print statement, it will only run the last commands. So you have to use a print every time. So yeah. Now let's look for tip for null value. As we saw, like there is some values with no like NaN value, but we cannot, there are 10,000 entries and we cannot like look for null values and individually fill those values like manually, right? Not all at once. So in Python, you can just use this command df dot is null and dot null dot sum. It will give you all missing values in each column. So is null gives you like a true or false table of if they have to have, if they have any empty values. And if you do dot sum, it will give you the total. And similarly, you can check for duplicate values like df dot duplicate dot sum. As you can see, AI is already giving me this recommendation. I'm going to accept it and run. So there are 7 duplicate entries. So we have some null values and we have some duplicate values. And I want all these to like be removed. So to remove the null values, again we have a command. We say df dot drop anything and run. So now you can see it has 8,389 rows. So it reduced from 10,000 to 8,000. So you drop all the rows with null values. And again, you can drop the duplicate values using drop duplicates. Again, AI is giving me the code and I can run it. Okay, so this command just drop the null values and give me the data frame, but we haven't like replaced the df, right? So we will drop any and then like replace our new df with that one. Now again we will do the same thing, df. We can call it df clean or something. Let's just call it df. Now if you look at the shape of df, 10,380 less than enough. Now we don't have any. You can again check for. You can use the same, copy paste the same command. We don't have any null values. And again, we can check for duplicate values. Here. So we have a clean data set now. So now here I dropped all the rows, right? But this is not a very good practice to like drop all of your rows because you lost some data, right? We had like a 10,000 entries and we didn't care about dropping the data set because we had enough. But in real practice, you try to find a way to replace those null values instead of dropping like all the values. We don't want to miss some important data. So there are techniques. And this is those techniques. This is out from the scope of what we will cover in this workshop today. But I'm just letting you guys know that there are other techniques we use. But for this workshop, we are just dropping them on. And now this was just basic data exploring data, like looking at columns, rows, and cleaning up and getting things ready. Now, now you can add like a text cell to write something. Let's say we are now doing data manipulation thing, and you can add a code cell and it gives you text. So there is text cells where you can write like the topics and notes, and there is code cells where you write your coding. And let's say you can create a subset of data sets using this data sets. Like let's say you just want the A's column to be in one data frame, and you can call it like df A's equals to df A's. So this df A's data again. It has only like A's. And you can use methods like mean, median, mode to find the statistics of this like only A's column. Let's say print. So AI is already giving me df A's of mean. We give you the mean A's. Similarly, you can go on pretty for the maximum, minimum, and the median. So maximum A's in my data set is 356. Which is not possible, right? 356 is a very high A's. So this is called outliers, right? And we also don't want outliers in our data set when we are like doing the analysis. And I mean, this is also a part of analysis, but when you go further, training a machine learning model, that we don't want any outliers in our data set. And similarly, there's a method like df dot describe. It gives you everything, like mean, median, mode, and everything. So it will give you how the count, the mean, minimum, and the maximum, and everything. And not just like a single column, you can have a new data frame from subsets of columns. Like let's say you have a large data set with thousands of columns, and you only want some important columns to be analyzed, right? So you can create a subset of those columns, and you can call it df like important columns. You can call it important columns or something, and df, and then just only for one column you use single braces, but for multiple columns you use like a dog. So this is you provide a list of the column names. So we have A's, let's say, and then there is income. These are important. Income, median, and then we have annual, premium. Now I have a subset of data set with only these columns. Again, if you say df important dot head, it only has these columns. And again, you can say you can create df important dot describe crime, and it gives you all the statistics summary of this particular data frame. Okay. So now that we have talked about how can you create subset and look for summary statistics of some columns, let's go into data manipulation. Now, data manipulation means like we will be changing some, we'll be actually replacing some values in the data set. And as you can see, like A's column has highest, the maximum value is like 356 or something. And A's cannot be like that high. So we are not finished with the data cleaning yet. Because we have outliers we want to. So we can use some conditions and filter the data set and only have the data set where age is like not more than 100 or something. So what we can say is like df new df a, then where my df is less than. So what this command is saying, I want a new data frame where you look for A's column where the values is less than 100. This will be my new data. And df, you can again df new dot describe. Now you can see it doesn't have like 356 because we filter these data frame to only have values of A's less than 100. Now it doesn't have any outlier. Now again, there is again a problem, like number of dependents is negative, right? So number of dependents cannot be negative. It's either 0, 1, or 2. So we would have to like filter again. I'm just gonna copy paste this, and I am going to say number of dependents greater than 0. Now my number of dependents, it can also be equal to 0. Now you can see it doesn't have any negative value number of dependents. And you can either use two different commands or you can use the same command. Like you can use like an AND condition. I want A to be greater than, like less than 100, and also number of dependents to be like greater than 0. So we can use these two conditions and like AND it. So I'm gonna just copy paste it here and say and That will be my getting an error. You can always use AI to troubleshoot your problem. Like fix the double and double and then yeah, I think so. Please second giving me some. Oh, you can replace A and D and I guess instead of double and. Yeah. We have new equals to yeah. Okay. Now I do not have any negative number of dependents and also I do not have high is values, right? So this is how you can like apply conditions and like filter your data set to get more like more cleaner and data sets that doesn't have any unnecessary values or any outliers. Now, now you can like let's say you only want a data frame with smoking status to be non-smoking. You want all the persons to have. You want a data frame where all your smoking status of person is like no smoking, and that is also filtering, right? So you can name it again smokers and df. So in my data set there in the entry if you see smoking status, no smoking, regular or occasional. Let's say I want first all the a data frame that has all like regular smoking status values. So can just call the smoking actually the smoking status of that person to be regular. Regular. It now has only like the smoking status regular person. And you can look for the insurance premium amount. It should probably have like highest premium amounts. And again, you can also, so this was about filtering data set and creating applying some conditions and creating a new data frame. Now you can also sort values in data. Now you have different columns, right? Age, gender. You have different numerical columns like age. You have annual premium amount. You have income in million, and we want to specify like we want to sort it by age or we want to sort it by income. So there is just a command like df and then dot sort values by something. Let's say I want to sort it by age. You say by equals to and then the name of the column you want to sort. And there is another parameter ascending. We want it in ascending order or descending order. Just run it. And now all my so df was my original data frame that I imported, right? But we did a lot of cleaning and we had it in DF new. So you can see the highest age is showing up to be 356. We already had a new data frame with everything clean, so I will keep it new. Now this one has like 72 to the highest, and then it goes 18 is the lowest. Similarly, you can sort it in different order by, let's say, income. Now let's sort it by income. Income in million. Let's say exercise for you to try out. Let's say from this data set, we want to find the smoking status of person having highest annual premium amount. So how can we do it? So what we can do is just sort the data set by the premium amount, right? So sort the data set by annual premium amount. I'm just gonna copy the okay. And you can see the highest annual premium amount is this, and you can just look for the smoking status of that person, regular. And that makes sense because person having regular smoking status is expected to have like a higher annual premium amount, right? So that was all about the storing data and then like filtering, data manipulating, and so on. And we have also covered some part of exploratory data analysis in this, right? We have looked for summary statistics, and we have sorted our data. We have like looked for the persons having highest annual premium amount. So these are all also the part of exploratory data analysis. So let's make a text cell, call it. Okay, as I said, you can use dfnew.describe method to get a summary statistics table of your data. Okay. You can see every like statistics values, mean, the minimum, the 25%, these are the median value, the first quartile, the second quartile, the third quartile, the maximum value, and counts. And these are only numerical columns, right? It doesn't, so .describe doesn't give you category. We also have categorical columns, like marginal status, number of dependents. So how can we check for types? You can just say df new dot d types. Yeah. And it will give you the type of each column. Like my age is a float, and object means they are non-numerical values. They are a string. And so each categorical values will have some unique values in it, right? If it's gender, it has male or female. If it's material status, it's gonna have married, unmarried, some status. So you can look for those unique values using df and the name of the column, like gender dot unique. So gender has male and female unique values. Similarly, you can look for smoking status. Smoking. Okay, so when you do value counts, it will also give you the categories, how many counts of each categories has. Like the smoking status has 1, 2, 3, 4, 5 different unique values, and and it have like these many counts of each category. And you can see there is one more problem with these entries, because no smoking, doesn't smoke, and smoking equals to 0. They all mean the same thing, right? So actually, we can replace these values like no smoking, doesn't smoke, and smoking equals to 0 with with the same value like no smoking. And that's the data manipulation. We're actually changing the value of in that data set. So what we can do, we can use a command again. So every time we use some command like I want the smoking status to be replaced. We want the doesn't smoke, smoking is equals to 0 to be smoked with like replaced with the value no smoking. And if I again so it now has only no smoking, regular, and occasional values. Right. Okay. I think everyone is able to follow up until now. So we have covered the very exploitative data analysis, exploring data, and now we are moving on to some visualizing data sets. So before we move on to visualizations, if anyone has any questions or anyone wasn't able to follow along, zoom in. Okay, thank you. The data visualization is like a really important thing, because all we have been doing until now is looking at the columns and the numbers and visualizing statistics. And if you really want to show like a non-technical person your findings, then it's visualizing those columns is really uh, really important. Like you can see, there are many visualization charts created by our previous data winners, and whenever you are visualizing, you compare by categories, right? Like you have male and female in this data set, and you want to compare whether male have higher premium amount or female have higher premium amount. Um, so we can group the data frame by categories. Like we can group by male and female, and you can look for the average annual premium of the males and females. Like you can see, one of the posters we compare categories by top and non-top graders, and the top graders, and we look for the average rating for top and non-top graders. And obviously, top graders had like a less rating than non-top graders, and this is how you can like uh, make analysis from the charts. And so, how can you group by categories in Python? So again, there is a command every time. So it's you don't have to remember all the commands. Like you just have to understand like what it's doing. Right? You can always ask AI to give you the command to group by categories. Now let's say I want to look for the average annual premium amount of male and female. So you say dot group by and then the gender, then annual premium amount, and then me. And it gives you like an annual premium amount of female. And you can easily see like males usually have higher annual premium amount than female. This is how you make analysis. And you can make a bar chart for this thing, right? So the same thing, you can also make a bar chart to visually show male and the female and their average annual premium amount. So how can we make bar charts? So now we will be using these other libraries. So until now we have only been using pandas, but now two important libraries. I'm gonna just copy paste it. So matplotlib You import matplotlib as PLT and seaborn as SNS. So these two libraries are really important for visualizations. And we use all the methods. And once you know how to import libraries and what methods are in these libraries, you can just hit that command and get the results. Like let's say you want to create bar charts of this thing, right? So what you can say is, so we can store this in some variable, average premium by gender or something. So we can store it in some variable, and we can say, okay, we can use this command sns.bar plot, and on my x-axis I have the average premium by gender dot index, and on my y I have like average premium by gender dot values. So index and then values, and run it. So it will give you the bar chart, and you can like this provide you a better picture of your result, right? You can just by looking at this chart, you can say male have higher than females. And you can also you can resize the charts using some commands like, and you use a PLT to set your figure size. You can set title for your bar chart. You can also like set the X and Y levels and so on. Like you can do PLT on figure and fix size to be 8 by 6 or something. And you can change it. And you can also set the title using plt.title. I will give you the title, average annual premium by gender. And again, yeah, this was bar chart. So you can visualize data. You can visualize a single column of data sets. So this was comparing by categories, right? So I can again use the same, just copying, pasting, and replacing the values with some other thing. Like, let's say I want to compare annual premium amount not by gender but by smoking status. So you just replace it with a column name, STATUS, and I will call it not by gender, by smoking, and then by smoking status. You can change the title, again, change the name, smoking, smoking. I think I mistyped the column here. Okay, now you have DF. So you can see like smoking, annual premium amount by smoking category. And obviously like regular smokers have higher premium amount on an average, right? And there is other type of chart called histogram. You can visualize the distribution of any column using histogram. And again, you use a command like, let's say you want to see the histogram distribution of the age column. You can just use this command sns.histplot. And KDE, if you do not have like a KDE command here, it won't give you the chord. So this chord is like an approximate function that that best fits this histogram. If you do not have that KDE, it will just give you the histogram. And histogram tells you like how many counts of each like number that each age has. So 20, around 20, there are like 200 people around 20. So this is how you can see the distribution. And again, you can use like, you can set the title, you can set the label and so on. Fix the size and so on. And you can actually change the color also. So I forgot the command. You can just ask the AI to and just ask copy paste to AI and change color to red or something. Working. Again, you don't have to remember all these commands, right? You can always ask AI to do this for you. So it like rewrote my program here. See? So you can add another like parameter and set your color. So I'm gonna keep it. I'm gonna accept what AI gave me. I'm gonna keep it. You can change color to be red, or you can say orange or something. Orange. It gives you a different color. It's this on the histogram. Then you can look for distributions of other columns as well. Just replace the values of age with the column that you want to look for. Like in another code cell. And next type of visualization is scatter plot. Now histogram and okay, let's also, the histogram gives you like a count and frequency, but you can visualize each column also using a pie chart, right? A circle with the percentage of values each pie chart has. So let's say I want to make a pie chart of smoking status column. I want to see how many percentage of people are like regular smokers and how many percentage are like occasional smokers. I will keep the, first of all, you will keep the counts of smoking status person. I mentioned this command before. You can get the count of smoking status categories, and then again you with command plt.py, and then you pass in these counts, and then you can pass more and more parameters. Like labels will be the index. So dot index gives you smoking is like regular, non-regular, and you can add more parameters and set your color, and you can also set like a figure size or something like this, and you can set titles and just hit run. So you can see no smoking in our data set. 54.5% of people were non-smokers, 31.5 were regular, and occasional 14.2% occasional. So this is how you can visualize the distribution using a pie chart. Now you can also look for relationships using scatter plots, right? You can look for, so this was all analyzing a single column of in your data set, and this was grouping by categories and comparing. But let's say you want to find the relationship, like the trends. You want to find a relationship between age versus the annual premium. Whether like how does age affect the annual premium. We can create like a scatter plot again, right? Again, using this command, sns.scatterplot. And then what data frame are we giving it? We are giving the df new data frame. And then my x is going to be the age, and my y is going to be the annual premium amount. You run it, it gave you this kind of scatter plot. And because we have like a lot of like around 8,000 entries or something, it looks messier. You can also scale it and then it will look better. So you can easily see like the trend looks like people of higher age has higher like premium amount, right? You can make this kind of conclusions using this chart. And again, like I'm just gonna copy paste everything. And you can set titles, you can set labels, you can set the size of your figure and so on. And you can actually change the whether you want to show it to be a dot value or like you want it to be some cross or something. And let me ask AI again. Uh, and this, currently, my each of these values is labeled using dot, but you can use cross or something. Yeah. So you can pass another parameter like marker, and you can pass in X. Now it's crossed. And again, you can like pass another parameter if you want a different color, like red or something. Now it's red. Marker could be different, like marker. This is how you can. So once you know the like very general command, you can always try to make like it on your own. You can change different values of parameters and make it more beautiful. You can change the titles. You can also actually scale it, scale those values. And I forgot to come on. You can call it like X or Y scale those values, and you will like see it this chart in a different scale. So let's not go into scaling now. So we can make conclusion from this chart. Like as age increases, you can see annual premium. You are expected to have higher annual premium amount. And we can also similarly analyze the relationship between like income versus the annual premium, right? So you just copy paste the same thing and just change the column names and values. Like now I want instead of age, I want income. Age and income. So this looks more messier. Change the color. It looks like there's no clear. We cannot see a clear relationship between income and premium amount. Because it's in million and then any premium amount, I guess it's not in million. It's just in thousands. We cannot see a proper and trend, but we could rescale it to see the proper trend. And people having higher income should have like more annual premium amount something. But in this data set, we cannot see a clear relationship. So totally depends upon where this data set is from. But we can still make conclusions that there is no any correlation or no proper relationship between income and annual premium. And we could just go ahead and dive in further to research and analyze why is this the case. So yeah. So I think we are pretty much to the end of the workshop already. This was all about data analysis and visualizations using Python. So you can say for relationships, you can compare different categories, you can explore data, you can clean your data. And there are a lot of more things you can do using Python that we covered here today in this workshop. And if you want to dive furthermore, you can always come to our lab, ask for more help, and always you can use AI as an assistant if you started and learn more. And there are more tutorials available online. State provides you free access to like popular learning platforms like Coursera and other LinkedIn Learning, so you can learn more complex like visualization and analysis techniques. I hope you enjoyed the workshop today, and if the rest of the part I want to leave for the audience. If they want to ask any questions, feel free to ask. Or if you didn't understand any of this, what I did, I know it went very fast, but we can always help you to if you have any questions.